So what we discussed last time, if you recall, is that one way to decompose the program is to break the program into objects. And then our program will become made up of objects, let's say object 1, object 2, and object n. Yeah. Now these objects, from where do we get them? From where do we inspire this object? From the real world, from the problem we're trying to solve. Now once we identify objects, us as developers, we go and create a class for that object. So what is a class?
The definition of the object.
Thank you very much. It's basically the definition of the object. And what's the difference between a class and an object?
Class contains object.
No, not really.
The class describes what the object has, and we can make many prototypes of many objects that in the same class.
Okay, yes. Not prototypes, but basically you can create instances or examples. So from a class definition, I can create as many instances as I wish. So an object is an instance, which is another way of saying it's an example of a class. And I gave you the analogy of, let's say, for the architect, he or she creates the blueprints of the house, and the builder, let's say in a compound, they just take that blueprint and create as many houses as they wish from that same definition, from that same blueprint. Yeah. So that's basically the idea. Let's just summarize it. In object-oriented programming, when we look at a running program, the running program will be made up of objects. Us as developers, for each object, we create a class that defines the object. And based on that class, we can create as many instances as we wish from the class. Now, a class, and by consequently also the object, is made up of two parts. What are these two parts that we discussed? Attributes and methods. Thank you. Attributes and methods. Okay. Now, what are attributes?
Properties of the object.
Properties of the object, or data or variables that hold data about the object. Okay. So this is a data about the object. And what about the methods?
The functionality, what the object is used for.
What the object can do for us. So these are the functions that the object can perform or can do. So when we create a class, in a class we define two things, the attributes and the methods. The attributes are variables and the methods are functions. That's basically what a class is. Now, if we take this and make it more concrete through an example, and let's take a super simple example of a banking system. So in a banking system, what do you think the most important object or the most important class in a banking system?
Account information.
Accounts. Thank you very much. So a bank, in a particular bank, a bank maintains one or many accounts. So in a bank, we find many accounts. Yeah. So that's what the bank is. The bank is nothing but managing accounts for people. Now, in an account, definitely an account is a class in a banking system. So now let's try to define what are the attributes and what are the methods of this class. So what do you think? What could be the attributes of the account class? What are the data we can store in this account class? So definitely when you create an account, you have to tell them your name. So here is the name of the owner of the account. The account has an ID, typically an integer number, typically. What else? Sorry? The date of? No, usually account does not have expiry date. As long as you are using it, it's fine. When you stop using it after 6 months, they will close it. Sorry? The amount of money. This is the most important piece of information in the account. What do we call it? The balance. From where did we get this verb or this keyword balance or this noun? Why can't we just call it amount in the account? Because? Yeah, no. The name. Why did we use the name balance instead of saying amount in the account or? No, because the bankers, because the people that will use our application use this terminology. So we use the terminology used in the problem domain. We use the terminology used by the people who will use our system. You remember the idea is to reduce the gap between our software and the real world. In the real world, what do we call the amount inside the account? So in our software, what do we call that attribute? We will also call it balance. Yeah. So that's from where we get the name. That's the idea of object-oriented programming, is reflecting real-world concepts and real-world ideas in our program. So balance, and what's the data type of balance? It's double, because you might have 500.5 Qatari riyal in your account. What else? What else is there? It could be other attributes of the owner. Because in the real world, the owner will be itself a class, but I just want to keep it simple for now. In real world, when you model this system, you will have another class owner, and here you put the owner, and then you define the attribute of the owner. Date of birth, nationality, ID card, and so on. But I want to keep it simple for now.
Maybe the type of
the type of account, the type, which is a string. What could be possible values of the type? What are the type of accounts you are familiar with? Saving, current, check account, and so on. Okay? I think this is enough. If we go to the bank, this is the most important class, which is account. And the major attributes are ID, name, type, and balance. This is enough, yes? To keep us moving. Let us just keep this simple for now. No need for this. We just need to focus on one class. So far we have defined the attributes. Next step is we will define the functionality of this class, which means we will define the methods. So what do you think? What will be the methods of this object, of this class? No, account is a class. What functionality this class can do for us? Very good. Add money. We can, in an account, all we can do, we can add money. Do we call this method add money? The bankers will be laughing at us. What they do, what's the term they use? What's the term they use? Credit, yes. In this context, they call it deposit. If you go to the bank, you would find even a form called deposit form. And when you want to take money out of the account, what they call this operation? Withdraw. Transaction is a general term that combines both. Yeah. But if you want to put money in the account, the technical term the bankers use is deposit. And if we want to take money out of the account, the technical term they use, withdraw. So which verb we will use in our design, in our implementation? The verbs they use in the real world. Are you following? Okay. So we will have definitely a deposit. We will have a deposit method. What do you think the parameters of this deposit method? When you want to deposit, what do you need as a parameter? The account, we already know the account information. The amount. Very good. Thank you very much. All you need to have is the amount. What's the type of the amount, the data type? Double, because it might be decimal. Although very rare, but you might be decimal, okay? All right. And what is the return type? What does it return when you deposit? Maybe some confirmation message of type string. So this is how I define this method, deposit. You can see here the class name is a noun, and the attributes are also nouns. These are nouns. But for the methods are, no, they all start with lowercase except the class name. The method, is it a noun or a verb? A verb. And keep this in mind. This is very critical. So the attributes are nouns and the methods are verbs because they do some action. Yeah. Now the other one, the other method that we have is withdraw. What does it take as a parameter? Amount. You have some amount that you want to withdraw. And what does it return as a return type? Some confirmation as a string. What else you can go to the bank and do with your account? Transfer, which is deposit and withdraw. Let's keep it simple for now. One more, check the balance. Thank you very much. Check the balance. In this case, what we will call it, the best way to call it is get balance. It doesn't take any input. And what does it return? Double. Very good. Let's keep it simple for now. This is a realistic but simple representation of what an account class could be. Yes? So the account class has two parts, attributes and methods. How many attributes did we identify? 4 attributes, the ID, the name, the type, and the balance. And how many methods have we identified? 3. Deposit, withdraw, and get balance. If you have this class, you can run small bank just with this class. It's simple enough. It's reasonable enough. Okay? It's clear? Now, this way of writing the class and documenting the class, this is called the class diagram, just for your information. The class diagram is nothing but a box that has 3 parts, a rectangle that has 3 parts. In the first part, what do I write in the first part of the box? The class of the class name. The middle part, the attributes and their type. The attributes and their type. And in the last part of the box, the methods. With the methods, I put the verb, the input parameters, and the return value. Input parameter and return value. Because remember, methods are, at the end of the day, what are methods? Are functions. You already know what a function is. It's a unit of code that takes some input, does some work, and typically return some return value. Okay? Now, this is how it looks on paper before you start coding. Let me show you another example, a little bit more clean. Here is another class diagram representing a grade book. You can see here it has the class name. These are the attributes and these are the methods. And this one is a standard, it's a standard way of visualizing a class, how it looks like in design before you start going and implementing it. Okay, now let us jump into Eclipse and try to implement this class. Implement it and see how we can make use of it. Okay, so let me create a new project from scratch. So here is a new project, Java project. I will call it Object-Oriented Programming Bank, for example. No. Okay, here is my class. Here's my project. I go ahead and create a new class. What I will call this class? Account. This is why we spent some time in the design. We designed our class. We made our decisions in terms of class name, attributes, methods. Now in the implementation, what is the implementation? It's a translation of these decisions or this design into code. So decisions already made, so I don't need to even to spend lots of effort here. I just translate this visual class diagram to Java program, to Java class. So what is the class name? Account. That's it. It creates a class. So you can see here already, this is the syntax Java uses to create a class. What is the syntax? You use the keyword public, the keyword class, followed by the class name. Then you put curly braces to start defining what a class is. Super simple. To create a class, use the keyword class, followed by the class name, and open your curly brace to start defining what? What are we going to define inside the class? The attributes and methods. Thank you. Okay, let's start doing the attributes. What are the attributes we have identified? ID, what's the type? Int ID. Name, what's the type? String, name. Type, what's the type? String. And the balance, which is double. Is clear so far? Are we done with the attributes? That's it. Attributes are done. Attributes are nothing but variables with type. These attributes will hold some data about the objects. Now it's now the turn of creating the methods. So what is the first method?
Deposit.
Deposit. If we forget, we go back to our design. Deposit, it takes the amount as double and return a string. So
Start with the easier one.
thank you. Okay, good. I like it. This is so good. I like this attitude. Start always with simple one. Get something up and running and working, and go for the more complex one. Very good. I like it. Yes. Let's do that. Double gets balance. It takes nothing and returns a double. What do you think gets balance will return?
The value and the balance.
The value in the attributes balance. So all it does, it will do return balance. That's it. This is now implemented. All what gets balanced, when you go to the bank and say, get me my balance, give me the balance of my account, they will tell you 500, 5,000, 5 million, whatever you have, they will tell you a number and you walk out. You achieve what you want. That's it. Now, yes. Okay. Now, remember, a class is some kind of entity that stores some values and it can do some actions for you. Okay? Those actions will depend on the class. Each class does different things. In this case, in this scenario, in a real world, what we can do with an account in a real world. If you go now, you walk out, you go to Q&B and you ask them, if I have an account, what I can do with an account? They will tell you, if you have some money in your home and you are worried somebody will break the door and take it, bring it to us and do what? Deposit it in your account. So we have a method called deposit. Now, if you see some nice car, you like to buy it, what you will do? Come to us, fill up a form, and ask us to withdraw money from your account and give it to you. Okay? Now, because you're putting sometimes money, withdrawing, you forget with time how much you have. You can come to us and ask, what is your balance? We will tell you. In simple terms, this is what you can do with the account. Of course, you can do other things like close the account, but let's keep it simple. Yes? It's clear? Now, get balance, what is the role? What is the implementation? What does it do? What get balance does? It just returns you the account balance. That's all it does. Yeah. So, where is the account balance in our scenario? Where is it stored? In this attribute balance. It will become clear as we start using the class. Okay. For now, just keep in mind this is just an example. keep in mind, all I want you to for now focus on, a class has two parts, attributes and methods. Okay, let's move on to the next method, which is deposit. Yes. So deposit as a method, it takes what as an input? The amount, which is double, and returns what? A string. Now, when you go to the bank and give them that 1,000 riyal deposit, what do you think they will do with that 1,000 riyal?
Add it to the balance.
They will add it to the balance. So what is the implementation of this method? Balance plus amount. So what we will do, we take this balance and we make it plus equal amount. We basically add the amount you gave them. They will take it and add it to this. Yes. And what I will do, I can return you amount. I can return you confirmation string. Deposit to your account. Your new balance is. Is this reasonable? Yes. If this one is confusing you, this one is nothing but balance plus amount. A more elegant way of doing it, we don't repeat balance, we just do plus equal amount.
Doctor?
Yes, please.
But when you return the amount, it's gonna print.
No, I'm not returning the amount. I'm returning a string. I'm returning as if I'm returning your little receipt saying 500 riyal was deposited to your account successfully. Your new balance is, if you had 500 and you deposit 500, what will be your new balance? 1,000. So this is just a confirmation message I'm returning. Yeah? Yes? Now, the next operation or the next method is withdraw. What does it take? Withdraw with A. It takes amount as double, and also it returns a string. String is just a confirmation. I could return the balance if I wish, but the bank manager, when I discussed with them, they told me return a nice confirmation message rather than just a balance. Okay? I didn't make up this. This is coming from the users or the business people. Okay? So the implementation of this will be very, very similar to this, except in here, what they will do with the amount when we withdraw, it will be reduced from your balance. And here we will say withdrawn from your account. This is your account. And your new balance is. Is this reasonable? Yeah? Is clear so far? Did we implement the class? Khalas, this is the implementation of the class. Very simple. I used the keyword class to create the class. I went ahead and created the attributes of the class, and then the methods of the class, and that's it. The methods, usually the methods they are using and manipulating, maybe reading or writing or changing the attributes. You can see here, get balance, what it's doing, returning the value of one of the attributes. What about deposit? Is changing the balance by adding the amount and returning confirmation message. What about withdraw? It's changing the balance by reducing the amount and returning a confirmation message. Is clear? Now the class is ready. We have developed it. What's the next step? If I want to use this class, what do I need to do? Create object out of it. This is the blueprint. This is like the architect created the design of the house. So you cannot go and take that design and go there and live there or enjoy that design. You have to take that design and make it a reality. Create some house based on that design or based on that definition. This is the definition. I need to create an instance from it, or I need to create an object from it for me to be able to use it. So what I will do, I will go ahead and create another class, because in Java everything is a class. So I create another class. I will call it application, or I call it main, or whatever. And in this class, I will ask Eclipse to create for me the main method. Remember the main? This is from where the program execution will start.
Is it in the original class we do not create any?
No, because the original class is just a definition of a class. It doesn't have, it's just a definition, and I will use it in another class. That's how usually we do this realistically how we do this. Okay, so what I will do here to be able to use the account class, I create an object from it. Okay. Now, for example, let me explain to you. For example, in this line, what I'm doing in this line. Anybody tells me what this line is doing? Declaring a variable named x of type int and assigning. You need to really use the terminology of the domain. It's very important. In any domain, there are terms, terminology, mustalahat. You really need to use them. Otherwise, you are not a person of that domain. You are from somebody else. You are from some other domain. They will call you mutatafil. If you start using the domain terminology, then you are part of the domain. This is the reality. Yes? So let's reread this using the terminology of the programming domain. What this line is doing? Declaring first. Declaring a variable named x of type int and initializing it with the value 10. That's what this line is doing. Is clear? Yeah. Okay. Now, if I want to create an object from the class, I will do something similar to this int x. Except, instead of int, I will use the class as the data type. And here, I can call it, let's say, Sarah's account equal a new account. I'll explain this shortly. So what this line is doing, anybody can read this for me? I'm declaring, what I'm declaring? A variable named Sarah's account. What's the type of this variable?
That type is
Account. And what I'm doing here? Initializing it with an instance of with account. I am basically, in another way to say it, I'm instantiating an object from the class. That's another term, instantiating, which means I'm creating. In here, I will call this, I'm declaring a variable. In here, what I'm saying, I'm creating an object called Sarah's account. What's the type of this object? Account. And then I'm initializing it with a new instance, with a new object from the class account. Are you following? Now, if you look very deeply here, what is int? What is int? It's a data type. What is account? It's a data type. So let me ask you, when you create a class, what are you creating in reality? A data type. This is a very, very important observation. I want you to repeat with me now. When I create a class, what I am really creating? When I create a class, what I'm really creating? A new data type. And this is basically the power of object-oriented programming. What object-oriented programming allows me to do? Create a new data type. This is a new concept to add to your tool set of programming. Because in Java, out of the box, Java has lots of types already. What are the types that come with Java out of the box? Int, string, double, all these are types. Now, these types are okay to get started. But in object-oriented programming, what it allows you to do? Create your own type. And these types reflect objects in the real world. Yeah? That is the power of object-oriented programming. So when you are creating a class, what are you really creating? A new data type. And what you can do with this new data type?
Anything we want.
No, I'm very precise what you can do with the data type.
Create objects.
Thank you very much. Create as many objects as you wish from that data type. It's clear? So I can have here in my app, I can have here, for example, Ali's account, Fatima's account, and so on. Millions. If you take QNB as an example, they will have the same account definition. They create millions of instances from it. And each account will have its own properties and its own methods. Is clear? So you create the definition once, and this, when you're creating a definition, basically you're creating a new type, and then you can instantiate it, or you can create as many objects as you wish from that type. As if it is a built-in type, there is no difference. Can you see here? Is there any much difference between this line and this line in terms of what it achieves in terms of goal?
No.
It's the same. Except in here, the data type is built-in. It comes out of the box from Java. But this data type is my data type. I created myself. Yeah? So object-oriented programming allows me to create data types that are specific to the problem I'm trying to solve, not just the generic types that comes with the language. Okay, so let's see how we will use this account, this object. So I create this object, and I start now initializing it. So I can put here ID. What could be the ID? 1, 2, 3. The name. Okay. What is the balance? When we start, the balance likely to be 0. What is the type? This is a saving account. That's it. What I did here, I initialize the attributes of the object. I initialize the attributes of the object. Now what I can do also, I can start calling methods. Deposit. She got this 500 and deposited in the account. Yeah. Now what will be the balance after this operation? 500. Now what I can do here, system system.out.println, and I can say something like this. Welcome, Sarah's account.name, your account balance. Your account balance is this gets balance. Yeah. If I run this, I should get welcome Sarah, your account is 500. Yeah. So you get the idea.
And then when we define the function deposit, the method deposit,
Yeah.
We want it to get a return message.
Yes, very good. Yes. So I can do here string confirmation message equals, and I can, if I wish, I can do it here. This is good point. Yes. In the first case, I ignored what is returned. In here, I didn't ignore it. I put it in this variable and displayed it. So if I run this,
But
yeah.
didn't you already did the string confirmation message in the class?
Confirmation message in the class. Now the class returned the string. Okay. So when I do deposit, what this deposit method did, it did two actions. What is the first action? Add the amount to the balance. The second action, it returned a string. Yes? It returned to me a string. Now the caller, when I call this method, by the way I call a method, I go to the name of the object dot the name of the method, and I pass the parameter. So this will do, when I run this one, it will jump here, take the amount. For example, the amount is 500. The balance was before 0. So 0 plus 500 is 500. So the balance is 500. Then it will construct a string. 500 deposited to your account. Your new account balance is 500. It will construct a string and return it to the caller. Yeah? What the caller is doing with this string, we're storing it in this variable confirmation message and printing it to the console. It's clear? Yes? And of course, I can do the same another account here. I can create another account. Here it is. And I can call this one Ali's account. I can create as many instances as I wish. All right. Ali only got 50 riyal for Eid. So, okay, so that's it. All right. That's it. Okay, so if I run this, you can see here I have two accounts. This is for Sarah, and this is for Ali. Sorry. Yes, because in here, yeah, because I didn't change this stuff. So in here, the accounts will be different, of course. The name is this, balance is 0, and current.
But that's a problem.
What do you mean a problem?
When you created both, they have the same number.
No, it's my mistake. It's my mistake because I did copy paste and I didn't change the values. But in the real world, when you create a new object, why did you create an object? Because you want to put different things in it. The information about Ali's account is different than Sarah's account. The reason why I didn't change in the beginning because I did copy paste and forgot to change it. But now somebody alerted me, and then I fixed it, and now everything is working as expected. Yes? But the idea here is to show you that once you create a class, what are you creating? New data type. What you can do with that new data type? Create as many objects as you wish. And then use this object the way you see fit. It's up to you. Is clear so far? Okay. Now let me just create one, just to concentrate on one and show you a couple of things. There are a couple of things not very good in our implementation. We are not following one very important principle of object-oriented programming called encapsulation. In this course, in many courses, as you can see, there are terms and terminology that you need to know and understand. Don't be scared, it's just a term. Encapsulation. This principle, this is an object-oriented principle. We are violating this principle. We are not respecting this principle that I will explain shortly. And this is not good. Okay? This encapsulation principle, what it says, you should make all the attributes private. Make the attributes private. What does this mean? Make the attributes private. Once I make them private, what happens to my app? There's an error here. What does it say? The field is not visible. You cannot just come and write to my attributes. It's my attributes. You cannot just come and write to it. This is an encapsulation. All the attributes must be private. Why do you think this is important? Don't allow direct access to the attributes. Yes, please.
So no one can change your blueprint?
No one, no, no. When we are changing, no, no. This is very good. Blueprint can only change by the programmer. Now, what I mean here we don't want to accidentally change some attributes. For example, the balance should not be directly changed. In real world, the balance you cannot change it directly. If you go to the bank, okay, and go to the director of the bank, or don't go to the director of the branch, go to the director of the QNB and ask them to change the balance. Do you think they can do it? No way. The balance is unchangeable directly. How you can change the balance? Deposit or withdraw. That's it. There is no other way. So by making it private, I am protecting it from change. Whoever wants to use this my object, they need to go through the official door to change the values of the attributes. What are the doors to change the attributes? By using methods. Yeah. Let me give you another example. One of the attributes of the student's object is GPA. Can somebody change the GPA here in QU? No one. Even if you go to the president, they cannot change your GPA. Believe me, no one can change the GPA because the GPA is a private attribute. How can you change the GPA?
Getting better grades.
Yes, like basically taking more courses and completing them and getting some good grades for them, then you can change the GPA. You can see here, there are some attributes that you should not directly change. Otherwise, you are basically exposing your system to errors and exposing them to misuse. So to close the door, what this principle says, encapsulation principle, what does it say? Keep all attributes private. Now, if you want others to read and write to those attributes, what should you do? Provide methods. So reading and writing should be through methods, not directly to attributes. You shouldn't write. Can you see here what this line is doing? It's assigning 1, 2, 3 to the ID attribute. Yeah. Now, how do I prevent this from happening?
By creating a method that will do this.
No. But how do I prevent this? By making it first private, yes? Now, is this a genuine thing? Is this common that I allow people to set the ID?
No.
In real world, yes. In real world, yes. We cannot set the ID. The ID is auto-generated inside the class, okay? But for simplicity, let's allow them. Let's allow people to set the ID. How do I allow people to set the ID? No, I won't remove the private. If I remove the private, what I will violate? The encapsulation principle. Yeah. So instead, I'll provide them a method called setID. What does it take as an input? Account ID. And what does this method do? It's basically ID equals. In class, don't think about the user. In class, there is no C in, C out, or there is no interaction with user. Never. Almost never. Don't do any interaction with the user in the class. Okay? Class has attributes, methods. Method do some work and return some value. They don't interact with user. Yes? Okay. So what I will do with this account ID, I assign it to ID. Yeah? You see the convention here. How do I name this class? How do I name this method that allows me to write to attributes? By using the verb. Which verb? Set. Set to write to attributes. And what do you think to read? Which verb should we use? Get. Okay. So what will be the name of the method to allow reading from the attribute? Get ID. And what this will do? Return ID. Yeah? So what I mean here, I made this one private, and I provided two methods. Set to write and get to read. And the convention is you use this keyword set followed by the name of the attribute, but the first letter I make it uppercase, capital. Yeah. Same thing for get. Now for balance, you see the balance here. I provided a get balance. Can you see it? Did I provide the set balance? No, I won't fall into that mistake of providing a set balance. Why? Because it's not allowed to change it from outside. If people want to change it, what's the door to change the balance? Deposit or withdraw. Can you see the power of encapsulation? You are in control. You control what to open for read and write and what to make closed, no read and write, or only read or only write. It's up to you. You are in control. Thanks to this principle of encapsulation. Yes? Now this one is now, of course, this is unhappy. How do I set the ID? What's the proper way of setting it? Dot set ID, and then I put this. Is this now happy? Yes, happy. Because I'm going through set. I'm not writing directly to the variable or to the attribute. You following? Okay, now the other advantage of doing it this way, I can do some validation here. I can do some validation. Do you think the account ID can be negative? Have you seen any account ID negative? I can do some validation here. If account ID is greater than 0, then I do this. Otherwise, I will throw an exception. I will not show you exceptions now because it's another topic. But what I'm doing here, what do we call this? What do we call this? This is validation. You see here the set method. What's the advantage of using set? Not only you have a door, you have a security door at the guard. You have the security. You have a guard at your door. You have some kind of validation that you can do before you allow people to write to your attributes. Can you see the advantage of doing set and get? So can somebody please summarize for me this principle of encapsulation? No?
Encapsulation,
Yes, please.
encapsulation allows us to keep the attributes private and prevent anything from being changed, except through methods.
Very good. That's it. I think this is good. Yes. Now, just to show you, in Eclipse, you can in fact ask Eclipse to generate for you the get and set. Can you see here? Generate getters and setters. Do we want a set for balance? No, thank you, Eclipse. We don't want this. Do we want it for name? Yes. Do we want it for type? Yes. Generate. And it will generate these methods for us. Yes. We don't need to write them from scratch. Okay, and then we go ahead and fix this. How do we fix this? Set name. And this one, do we do this? No way. And this one, what we do? Set type. Set type. Please give me 2 minutes. I just want to show you one thing and let you go. And here, do we read the name directly? Get name. That's it. Is encapsulation people happy? Everyone is happy? Yes, everything is happy. And the program runs as it was before, except now, are we respecting this principle? Yes. One last thing, you can see here what I'm doing in this line. 2 birds, 1 stone. Declaring and initializing. Declaring, initializing. I want to do the same here. I want to put these values here. In one line, I declare a variable or create an object and initialize it in the same line. Yes, we can do this. So I don't need to do 3 lines. In one line, I do all of this. Of course, in my class, I go ahead and create a function. That has the same name as the class. And in here, what this function will take? It will take the ID, string name, and string type. Okay, and then it will do this.id. This.id refers to the attributes equal id, and this.name equal name, and this.type equal type, and balance equals, what do you think? 0 in the beginning when you create the object. That's it. In here I can do this, so I no need. The reason why I put this, because this variable is the same name as the attribute. If I just put it without this, the compiler will be confused. Which ID are we talking about? I'm lifting this confusion by putting I referring to the attributes. Take this parameter and put it in the attribute. This method, this special method, we call it a constructor. We call it a constructor. And with what this method allows us to do, in one word, what does it allows us to do? To initialize the object at the time of creation. To initialize the object at the time of creation. So I know there's lots of things we have covered today, but it gives you a very good glimpse of what really object-oriented programming is about. Please go through the slides, go through the examples, and enjoy the lab. The next session I will explain this in much more details through more examples. Thank you very much.